talk about what we were going to talk about in the workshop, and that's using AMOS to conduct path analysis and structural equation modeling. So what I want you guys to first go ahead and do for me is to grab up on Moodle the data set, and you'll find the data set as always in the workshop materials section of Moodle, which is here. And just a brief overview, we've got the data set key, which essentially gives a background to the data set. You've got the checklist that I wrote that gives you an overview of the steps in structural equation modeling. And I've also put down in Moodle for you there a list of fit statistics. So we talked about fit statistics today in the session, but there are a number of other fit statistics that I mentioned, and those are contained within that document there. So it just gives you a bit of background really on what they are and what the particular cutoffs for. So anyway, let's go ahead and download the data set for this week's workshop. Now what we're going to do with this data set is run, first of all, path analysis, and then we're going to run some structural equation modeling. Now this is a data set that, as I suggested in the workshop, it's taken from a couple of years ago now. Youth sport participants, boys and girls, and we asked them to give us an indication of their levels of engagement, behavioural engagement, so levels of effort, persistence, concentration, attention, and so forth. We asked them to provide information about their levels of psychological need satisfaction, so how autonomous, how competent, and how related they felt in sport. And then we also asked them to give us an indication of their perceptions of how autonomy supportive their coach was. Now I've cleaned this data set up, I've imputated missing values, and I've also removed any univariate or multivariate outliers, so the key sort of screening procedures have already been done. And what I've also done is I've provided, based on the items for each of the scales, I've also provided an aggregate score, so an overall variable score for our autonomy, sport engagement, and need satisfaction. Now I'm going to run some basic mediation models with this data. So we've looked at mediation using regression analysis last week. We're just going to do exactly the same this week, but in path analysis. And so to do that in path analysis, what we're going to do is use these three observed variables, and then we're going to use the indicator variables, the items for all of the scales, to run some structural equation modeling thereafter. So what we're first going to go ahead and do is run some path analysis, and what I want you guys to do is, once you have AMOS installed on your machines, or you're on a university computer that has AMOS installed, and then I want you to go to Analyze in the SPSS data set, and I want you to click on IBM SPSS AMOS, and what that will do is it will bring AMOS up for you. Now, aware that you folks are new to this software, and so like anything, when you come across it for the first time, it might seem a bit daunting, and there are certainly a lot of things to remember when we're running analysis in SPSS AMOS. But don't be too worried, because it's not as difficult as perhaps it might seem. So I just want you now to become familiar with AMOS, what it looks like, how it feels. There's a number of things that AMOS provides that make it a very user-friendly software. So the first thing it provides is a interface that you can change and to suit whichever model you're going to run. Now, at the moment we've got a portrait interface. So if you click on interface properties in view, one of the things I want to do first of all is turn our screen setting here to landscape. So we've got a little bit more room to play with in our path model. And then what I want you guys to do is make sure that the data file that we've just been working from is the same data file as we've just downloaded. And you can see here we have an N of 153, which corresponds with the N of the data set that we're working with. So far so good. So the data set's inside the software. Now what we're going to do is click on the list variables in dataset icon, which is 3 rows down, and it's the white horizontal box icon here. And what this will do is it will bring up the variables in our data set, and essentially these are exactly the same variables as what we have in our data set here. So the variables across the top are reflected in a list of variables that come up in AMOS. So for path analysis, we're not interested in the latent variables, we're interested in the observed variables, the things that we've measured and calculated. So let's go ahead and set up our model. And all we do to do that is we drag each of the variables that we're interested in and we pull them into the interface. Now we're going to test a path model here which stipulates autonomy support is predicting engagement through psychological need satisfaction. So it's a very simple mediation model. And what I want you to do is draw that mediation model as we have been drawing it in the mediation session last week. So you take the draw path and you then use that here, draw path arrow, to draw a path from one variable to another. Click on autonomy support, hold it down and point it to psychological need satisfaction, then click psychological need satisfaction and point to engagement. And then we want to include the direct effect as well of autonomy support and engagement. So we'll draw that path too. Now this little wand here is just a way to touch up the variables just to make sure that everything's nice and clean. Now, once we've drawn our model, we need to do two things. The first thing that we need to do is add a residual unobserved variable to the dependent variables in our model. And this is essentially so that SPSS has somewhere to put the unexplained variance in the model. So the unexplained variance in engagement that isn't accounted for by psychological need satisfaction and autonomy support, and the unexplained variance in psychological need satisfaction that isn't accounted for by autonomy support. And these, if you can think back to multiple regression, are basically residuals. They're the difference between the estimated or the regression line, the estimated prediction, and the actual values, the actual cross-section of autonomy support and psychological need satisfaction. And that difference, of course, is the unexplained variance that the regression line doesn't explain in our model. And the second thing we need to do is label those unexplained variables, because SPSS doesn't like variables that are left unlabeled. So all we're going to do to that is go plugins, and we're going to go name unobserved variables. What that does is it creates a little E1, E2, so error 1, error 2. And essentially that's just telling SPSS error 1 and error 2 are the residuals, the unexplained variance in psychological need satisfaction, the unexplained variance in engagement. And so now what you've done, folks, is you've created a path model in AMOS that's ready to have an analysis run upon it. Now what I want you to do before we go into running the analysis is have a click on our analysis properties, and we're going to tell SPSS what output we want. So we're going to click on analysis properties, then we're going to click on output. Now what we want is a standardized estimate. So these are the standardized regression coefficients. We want the indirect, direct, and total effects, remember from last week for mediation. We want the squared multiple correlation. So this is the variance explained in our outcome variables. And I think that's going to do it for now. So we'll leave that there. So we'll have standardized estimates, we'll have square multiple correlations, we'll have indirect, direct, and total effects. And now what I want you to do is go ahead and run this model. So we go analyze and calculate estimates. And then what we do is here, where we have the input path diagram and the output path diagram, once we've run the analysis, we can then look at the output path diagram. And here what you'll see is some interesting stuff. So these are the unstandardized estimates of autonomy support on psychological need satisfaction and engagement. You can see here that the unstandardized regression coefficient between autonomy support and engagement is 0.44. So for every 1 unit increase in autonomy support, psychological need satisfaction increases by 0.44 units. And the regression coefficient between psychological need satisfaction and engagement controlling for autonomy support. So for a 1 unit increase in psychological need satisfaction, holding autonomy support constant, there's a corresponding 0.59 increase in engagement. So what do we have here? We have a positive indirect effect. Okay, positive effect. Autonomy support predicts increases in needs, which it predicts increases in engagement. But we also have some leftover variance here in the direct effect. So this indirect effect doesn't explain all the variance between autonomy support and engagement. It just predicts some of the variance explained between the two. Now I want you to also recognize that SPSS can give us standardized estimates. So these are the estimates put back in their original units, and you can see that some of the relationships have strengthened here once we look at the standardized estimates. Also, when we look at standardized estimates, you can see the variance explained in the outcomes. You can see here 39% of the variance explained in psychological need satisfaction by autonomy support, and 50% of the variance is explained in engagement by autonomy support and not psychological need satisfaction. So quite a large amount of variance explained, and the effects are also positive and quite large. And this is really simple mediation that we looked at last week. There's a mediation effect, but it's not quite fully mediated. So, 2 things about this model. The first is that this is a just identified model. Remember we talked about just identified models? That's a model where there are 3 unknowns and 3 pieces of information. So as a consequence, we have 0 degrees of freedom, and the model fit will be perfect because the correlations that are implied from this model will precisely mirror the correlations in the data set. And we know it's a perfectly, this is a just identified model because the chi-square statistic is 0. So the implied and actual correlation matrix perfectly reflect each other. And also all of our fit statistics are at the perfect level. Okay, so here we can see that CFI and IFI, TLI are a perfect 1. So this is what's called a just identified model. There's just enough information to calculate for the correlation matrix. And we could run this exact analysis in regression using the procedures that we went over last week. So there's not a great deal of difference here between what we did last week and what we're just doing now. But where AMOS and structural equation modeling comes into its own is if we say to our model, we think that this relationship is fully mediated. We don't believe that this path is necessary in the model, and so we're going to take it out. And we can take it out by using the erase objects, and we just erase the path. So now we have 3 unknowns, 3 correlations, but only 2 pieces of information. And this is an over-identified model. So what AMOS will do is it will take this indirect effect and make an estimation about the correlation between these 2 variables from this indirect effect. Why? Because of Wright's tracing rules we talked about in the lecture. So Wright's tracing rules essentially that all the correlation between 2 variables can be represented as sum of all paths obtained from each of the possible tracings. So this path here, or this correlation here, is a function of both the indirect effect and the direct effect. So of course, if this path isn't needed, if the C path here isn't needed, then AB, the multiplication of these 2 paths, will closely approximate C, because C would be 0. And as a consequence, this path wouldn't be necessary because AB would provide an approximation or a close approximation of the path. However, if C was needed in the model to approximate the true correlation, then you'd find that AB wouldn't closely approximate the correlation, and as a consequence, the path would be needed in the model. The difference between the estimated and the observed path would be so large that we would need it in the model to have a decent degree of fit. So paths rights tracing rules, which go back all the way to the 1930s, essentially give us a means of estimating a correlation matrix from the paths that we give at AMOS in the model. So I'm going to go ahead and take that path out, and I'm going to see what difference that makes to our model. And we can see here that it doesn't make a great deal of difference. So this relationship here is strengthened slightly in the absence of a direct effect, and there's a little bit less variance explained. But essentially, and this of course is the same, because it's exactly the same regression equation. But essentially we have a similar set of findings here, but what you will find now is that we have a chi-square statistic. And we have a chi-square statistic because there will be some difference between the observed correlation matrix, so the correlation matrix observed in the data, and the implied correlation matrix based on this particular model. And that difference will be in this particular correlation here. So if we go to the residuals, I'm just going to have to, request those residuals in SPSS, in AMOS. You don't have to do this, by the way, but I just want to show you that what's happening here. So we take the residuals, and we're going to run that again. Where are my residuals? Okay, residuals, here we go. So you'll see here that the relationships or the correlations or the covariance between autonomy support and psychological need satisfaction and autonomy support and engagement, we have a perfect correlation here because this relationship is stipulated in the model, and also this relationship here between psychological need satisfaction and engagement. Okay, engagement, psychological need satisfaction is also stipulated in the model, and so reflects the relationship between the variables. However, we don't have this path in the model, and so the implied correlation can only be taken from the product of these two paths. We don't have the direct effect to add to it, and so there's likely therefore to be a difference between what the implied correlation is and what the actual correlation is, and of course that difference here is reflecting the residual covariances, and the difference between the implied and actual is 0.299. So that would suggest to me that there is an element of misfit in this model, and we can determine that misfit from some of the fit statistics that that we are given by SPSS. Now you can see here that even though that relationship or that path isn't stipulated in the model, we still have a decent fit. But you can see here the Tucker-Lewis index is slightly lower than what we might expect, and also the root mean squared error approximation is slightly higher than the cutoff value. So you can see here that that path being absent from the model is causing a degree of misfit from the model. And what this tells me is that we can't justifiably leave this path between autonomy support and engagement out. It needs to be in the model because the model does not well approximate the data without it. And that essentially is path analysis, guys. And one of the things that we can do with path analysis, of course, is exactly the same things as we did last week. We can look at the indirect effects. So you can see here that we have an estimation of the indirect effect of 0.421. And if we wanted to test the significance of that indirect effect, well, then we just do exactly what we did last week. We request bootstrap resamples and confidence intervals of 95%. When we do that, we can get an estimation of the significance of our indirect effect. You can see here that when we go to matrices and indirect effect and our confidence intervals here, we have an upper bound and a lower bound. And you can see we also have a two-tailed significance, but you can see here that the upper and lower bounds of the 95% confidence interval don't include 0. So we can say that this indirect effect is positive and significant. So the relationship between autonomy, support, and engagement is carried through psychological need satisfaction, but it isn't fully mediated. The model is telling us that we need this path. Okay, and that's path analysis, guys. That's how we run path analysis in AMOS. And it's relatively straightforward. Okay. But we've talked about, haven't we, the problem with running path analysis with observed variables. And that problem is something called measurement error. You can see here that we talked about in the workshop that there's variability in a variable, and if we just take the aggregate variability, we include the true variance and the variation due to error. And of course, we need to rid ourselves of that error because that puts an upper limit on the correlation. So what do? Well, we distill our measurement or our items down to their common variance using latent variables, which separates the common variance between each of our items and the unique variance. And of course, the common variance between our variables necessarily rids ourselves of error, and it also rids our measurement of the unique variance that is explained by each individual item that isn't relevant to the construct of interest. So it's important that when we do modeling, we take into consideration the common variance of our constructs so that we get at the true measurement of interest, or the true construct of interest. So now we're going to move then to testing this model using latent variable structural equation modeling. So instead of taking the measured variables and running a path analysis, we're going to take the latent variables and run structural equation modeling. So the structural equation model is really quite straightforward, and the way that we run this in AMOS is we click on the latent variable icon, and all we're going to do is run a latent variable that looks something like this. So draw the oval, click on it 4 times because we have 4 indicators of autonomy support. I'm going to do another oval here, and we're going to click on it 3 times because we have 3 indicators of need satisfaction. And finally, we're going to do one more oval here, 1, 2, 3, 4, 5, because we have 5 indicators of engagement. All right. Now what we're going to do is draw the residual. Remember, we need to tell SPSS that there will be some residual variance in these variables that isn't explained by our variables. In fact, actually, let's not do that yet. Let's take that away for now. Let's run the measurement model first. So we have our latent constructs. Again, we're going to click on the list variables and data set, and this time we're going to draw across our items. And what I'm doing here is I'm putting item for autonomy support 1, 2, 3, and 4 in the observed variables space. I'm putting autonomy, relatedness, and competence here in the observed variable space for need satisfaction. And then I'm putting the items for engagement across here in the engagement latent variable space. Now what I'm going to do is go ahead and right click on the latent variable, and I'm going to click on object properties. And I'm going to label this as autonomy support. and I'm just going to differentiate it from the autonomy support variable in the actual data set so that it doesn't get confused. I'm going to label this PNS, and again I'm going to put a 1 on the end, and I'm going to label this engagement and I'm going to put 1 on the end. Now what we have is 3 latent variables, 1 capturing autonomy support, 1 capturing psychological need satisfaction, and 1 capturing engagement. Now to test the measurement model, so I'm not testing any structural relationships here. I'm not testing to see whether autonomy support predicts needs, which predicts engagement. I'm just testing the measurement model, the extent to which each of these items loads adequately on their respective factors. I'm going to take the correlation covariance arrow first of all, and I'm going to draw all possible correlations between the variables. The reason is because I'm assuming that these variables are interrelated, because we are after all looking at the relationships between them. There's a hypothesized relationship between them. But I'm also looking to see whether the factors or the items load on their respective constructs. What I'm going to do now is go ahead and name those unobserved variables, name those error sources of error. Now remember, of course, these sources of error are to do with measurement error, and they're also to do with unique item error. So we need to rid our model of this error. So we take that away, and then we're left with the common variances captured by these items. And of course, the common variance measures the construct of interest. We're not interested in the unique variance that each item has. We're measured in what the items measure in common, and that's autonomy support, psychological need satisfaction, and engagement. So let's go ahead and run this model. First of all, let's just check that everything's in order here, which it is. So let's just go ahead and run this model. Now, of course, if you do get that error message, it means that there's an item called engagement 1 in the data set. So that's no good to us. So we're going to call this engagement 9 instead and run the analysis. All right, okay. So now you'll see that we have a set of correlations between the variables. Now these correlations are called error-free correlations because they necessarily don't contain error between the latent variable sets. The error has been removed from the latent variables through this process. And so all we're left with is the raw correlations between our study variables. Now what we're really looking for here is that we have a good model fit, because a good model fit will tell us that the items load well on their respective factors, but also that there shouldn't be items in one scale that are perhaps belong in another, or there's any cross-loading. So the model fit's really useful here to give us an indication of how well our measurement model is performing. You can see here that chi-square is significant, but we know the higher our sample size, the more likely we are to have a chi-square that is significant. So what we're going to do for now is ignore that, and we're going to take a look at our CFI, our TLI, and our root mean squared error approximation. You can see here this measurement model seems to be performing quite well. So the CFI is over 0.95, as is the Tucker-Lewis index, and we have a root mean squared error approximation that is below 0.10. We can also request the standardized root mean residual, and we know from our understanding of standardized root mean residual that essentially this is the aggregate of the squared residuals in the model, and we can see here that again is below 0.08, so indicative of good fit. So our measurement model here is good. It fits well, the relationships are strong, and it indicates a nice approximation of the observed data. So we have a good measurement model. We're now going to look at the relationships between these latent factors, and this is where we finish the lecture. So what I'm going to do now is I'm going to draw paths that run from autonomy support to psychological need satisfaction to engagement, and the direct effect. What we're doing here is exactly what we did in path analysis. We're looking at the direct and indirect effects of autonomy, support, and engagement through psychological need satisfaction. But this time, we're using the true construct scores rather than the observed variables. And so our correlations are necessarily now estimated without error. So, what's happening? Well, not only are we testing the measurement model, but now we're also testing the structural model, the hypothesized relationships between our variables. And when we go ahead and run this model, before we do so, remember we need to tell SPSS that there's error in our measurement. So we're going to go ahead and name those variables. Error. There's going to be error in these variables. This is the independent variable. There is nothing predicting it, and so there will be no error variance associated with it. But there are predictions occurring for psychological need satisfaction and engagement, so we need to capture those by error. And essentially all we're doing here is exactly the same as what we did in multiple regression and in path analysis, but using latent variables. So this is a simple regression, and this are multiple regressions. So let's see what's going on here. Well, now we've got slightly more variance explained, which is what we would expect to see. Remember, when we're using measured variables, it gives an upper limit to our relationships. But essentially, we have the same pattern of effects here, just using latent variables. So positive effect of autonomy support on needs and a positive effect of needs on engagement. But again, this relationship still exists, which would suggest to me that it is needed in the model, but we can find that out in a moment. So we can see here that when we go back to our model fit, we have a significant chi-square. Remember, it's not a particularly good measure of fit. So what we're going to do now is look at our other measures of fit, and we can see again that we have a good fit for comparative fit index, the Tucker-Lewis index, and a good fit for the root mean squared error approximation. Here. And also when we run the standardized root mean squared residual, we find that we have a similarly good fit to the data. Now, one more hypothesize that, okay, this is a fully mediated effect, just like we did with the path analysis, and we're going to remove this path. So we're just interested in a purely indirect effect. We're not interested in the direct or total effects. Now we're going to run that model again. And hopefully what we'll see now is that there's a slightly worse fit, so the chi-square is higher. And when we look at the CFI and the Tucker-Lewis index, there's a slight decrement in fit. Likewise, the root mean squared error approximation is slightly higher and now is above the 0.8 cutoff. And if you look at the standardized error map, we also find that that has also increased slightly. What this suggests is that the direct path is probably needed in the model, but that nevertheless there is still a decent fit when it isn't in the model. And so really it's up to you as researchers to decide whether is the theory stronger if we suggest that the relationships are fully mediated. That is to say, the self-determination theory hypothesizes that the relationships will be fully mediated, and I would suggest that they do. I would suggest self-determination theory doesn't stipulate any other process through which autonomy support would impact engagement. So as a consequence, it's justifiable in those circumstances if there's a strong theoretical justification to leave that path out of the model. But in any case, you can see here that the CFI, the TLI, and all these fit indices, remember we went through in the workshop, both of these are essentially the extent to which the implied model differs from the worst possible model. So it's a model that doesn't include any correlations. So obviously the higher the better. And the root mean squared error approximation is the difference between the implied model and a perfect model. So obviously the smaller the value, the better. And that's structural equation modeling, folks. That's essentially what's happening when we run these analyses in AMOS. And I've put some information up on Moodle about how you write this analysis and how you run it. The lecture slides are also a useful backdrop to some of this work. And what we're going to do next week, when we get back in the workshop computer room, is use a remote desktop to bring up AMOS, and then we're going to work through this analysis on those computers ourselves. But I just thought I would provide you with this overview of how SPSS is run, some of the functions and things that need to be pressed before we can run the analysis, and what some of the output means. If you have any questions, give me a shout. I'd be more than happy to answer them. But in the meantime, have a great weekend, and I'll see you next week.